Today we're going to be crafting quadratics by finding the 5 main points on our parabola. So here's our parabola. This is just a reminder of all of the different pieces that we can have on a parabola. Down here is your minimum value, or if the parabola was upside down, it would be your maximum value. It's called the vertex. How do we find the vertex? To find the vertex, you're going to do the opposite of b over 2a and then plug it in. That'll make more sense when we actually start doing it. We also have these lovely points, which you should be very familiar with. What did we call those? Those are the x-intercepts. Now, when we have x-intercepts, how do we find those? We learned several methods to find the x-intercepts. One option is factor. Another option is quadratic formula. We have just solve by square roots. That's if there's no b value. And then we have complete the square. Okay, what are the other points that we can find? We can also find this point down here. This is called the y-intercept. It's where it crosses the y-axis. If you're looking at a quadratic in standard form, this is going to be your c value. Now, we also have this really important piece called the axis of symmetry. The axis of symmetry is a line that goes through the vertex. And what happens is, if you fold your paper on that line, both sides of your quadratics should line up, which means they are mirror images, which means any point on the left will line up with a point on the right. So the easiest way to find that fifth point is by counting how far one of your points is away from that dotted line and going the same distance on the other side. Now also notice the mirror, or the axis of symmetry goes through your vertex. It's an up and down line, so it's an x equals line, which means it's x equals negative b over 2a. So to find your axis of symmetry, we have x equals the opposite of b over 2a. So those are the 5 points. Now remember, when I'm referring to a, b, and c values, we are looking at a quadratic in standard form, which you guys should have seen before. Y equals ax squared plus bx plus c. It's the numbers in front of the x's that those a, b's, and c's are labeled. All right, let's try one where we're finding all of the different pieces. Now, before we get started, let's talk about one more thing. If I have a quadratic where I have a negative out in front of it, so we have negative ax squared plus bx plus c, that is how you get your upside down parabola, your hill instead of the u. All right, here's number one. We're going to find each of the pieces. So the first thing that I have kids do is list everything you need to find. So I know that I need to find the x-intercepts. I need to find the axis of symmetry. I need to find the vertex. And I need to find the y-intercept. And then we need our mirror image, but that one I can just count. So let's do x-intercepts first. Remember, you have more than one method. If you don't like the method that I choose, use a different one. We should get the same answers. I'm going to factor because I like factoring. If it's factorable, I always factor. So for this one, if I factor this, I'm going to draw my 2 parentheses, fill in x and x, because what times what is x squared? That'd be x times x. Now I need factors of 14. I have 1 and 14 and 2 and 7. 2 and 7 is how I'm going to get that 5 as the middle term. It's a positive 5, which means my 7 has to be positive. My 5, or my 2, sorry, is negative. So 7x, negative 2x, that gives me my 5. Positive 7 times negative 2, that gives me my negative 14. So this is factored. Now remember, when we're solving, we have to set each of those equal to 0. and actually solve down for x. So my actual x-intercepts are -7 and +2. All right, axis of symmetry. If we look at our notes again, axis of symmetry is a x equals line, and it is x equals the opposite of b over 2a. Well, my b value is 5, so the opposite of that is -5 over 2 times my a in front of the x squared is 1. -5 divided by 2 would be -2.5. So that's my axis of symmetry. Now, we also have our vertex. What do we know about our vertex? We know that the vertex, the x value, is the same as the axis of symmetry, so I'm going to plug that in. How do we find the y value? If we go back up to our notes, it says plug it in. So we're going to take what we found for the x, plug it in to find the y. Be very careful when you plug this in, because signs are going to make a huge difference. So when I plug this in, I'm going to do -2.5. Now that negative is not outside of the x squared, it's the number we're plugging in, which means the negative is also being squared. Plus 5 times -2.5 minus 14. I'm going to show you this step by step. So -2.5 squared is 6.25. 5 times -2.5 is minus 12.5 minus 14. So I have 6.25 minus 12.5 minus 14, which leaves me with my y value for the vertex at -20.25. My y-intercept, that one's super fast to find in vertex or in standard form. That is your lovely c value. So I'm going to come back up here to the top to my original. My c value is at -14, so that's my y-intercept. Now we can go ahead and plot this. So I'm going to erase this just so we can stay on the same page. Here's my axes. It's not going to be perfect because I don't have a perfect grid here. I'm going to put a bunch of lines on here. I didn't go down far enough. All right, so my x-intercepts are at -7, 1, 2, 3, 4, 5, 6, 7, and 2 over 2. There we go. X-intercepts. Axis of symmetry, -2.5, which is right here, which means I have a dotted line through that point. Vertex, -2.5 down 20.5. So I'm going to come all the way down here, just past 20. Y-intercept is at -14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, about here. And then we have our axis of symmetry. So I'm going to count from the y-intercept to the dotted line. I go over 1, 2, and a half. So I'm going to do that to the other side. A half, 1, 2. And here's my mirror image. And that makes our parabola.